what do we do now that we know how to combine like terms? We're going to, since we know what our coefficients are, our variables are, and our constants are, we're going to look at combining like terms. So what happens when I have a g plus g plus g plus g plus g? So we're going to just rewrite each expression using multiplication just to warm up. So you can pause the video here and do the warm up for frame 1 and do the warm up for frame 2. I'm going to go over them with you. So let's take a look at the first frame. Whenever we're adding something, for example, like 1 plus 1 plus 1 plus 1, we know that it's going to be a multiplication of 1 times 5. Okay? Now we don't have numbers. Now we just have variables. So we're going to do the same thing, except since we're not multiplying here, we're not going to have exponents. Since we're adding, we're going to be multiplying. So my first answer, I count how many g's I have because I'm adding, okay? So I count how many g's, 4, 5. So that means that I'm multiplying 5 g's together. Let's look at our next one. My t plus t plus t. There's 3 t's. So I'm multiplying my t 3 times. My next one, d's. So I have 1, 2, 3, 4, 5, 6, 7. So I'm multiplying 7 d's. K's. I have 1, 2, 3, 4, so that gives me 4 k's. And that is how I combine my variables together to simplify and make it easier for myself. Okay, in the next one, we're going to combine like terms, match each pair of equivalent expressions. So we're looking for terms that are equivalent, meaning they're equal to each other. So let's take a look at 2 times 6g. Okay, I can distribute and multiply my constant by my coefficient because there's a multiplication sign here. So 2 times 6 gives me 12g. 9 plus g plus 12. Notice how these are in parentheses. So what I can do is because there's a plus sign here, I can get rid of my parentheses and I can just say 9 plus g plus 12. Well, 9 plus 12 gives me 17. So that leads me there. So again, I get rid of my parentheses and I'm going to combine like terms. So this 9 and this 12 are the same, they're both constants. So that gives me 17. 9 plus 12 gives me 17. And I have a g left over. Next, I have g plus 8. I can distribute that 8 into 2 plus 6. They both are equivalent. And last but not least, 4 times g times 2. I have 2 constants here that are the same, so I can multiply them together because there's a multiplication symbol on both sides. So it's telling me everything is going to be multiplied. So 4 times 2 is a constant. That gives me 8g. Let's take some notes. Like terms is a phrase we use to basically tell people that our expression has something in common. So in algebraic expressions, like terms have 2 important things in common. Like terms have the same variable, that means the same letter, and they also have the same power. Remember how we've been doing exponents, okay? If it has the same power, that little subscript above the number is your exponent. That is the same power. So it has to have the same letter, and it has to have the same power, that same little subscript. So a variable with no coefficient has a coefficient of 1. And terms that take the operation symbol directly to the left of the coefficient. That means if there's a subtraction sign in front of a 1, that means it's a negative 1. Constants are like terms. Let's take a look at our next frame. So what they're saying is our constants are like terms, meaning this 20 and this 9 are both the same terms. Okay, so in order to separate and organize my terms, I'm going to do it in different colors, and I'm going to do it in different shapes. Sometimes you guys are writing with a pencil and you can't do it in a different color. You can always do it in different shapes. So let's look at some like terms, okay? I have a 5x. Now I'm going to look for everything that has a number and an x. I look around and I see 20 doesn't have that. This one has an x squared. It has a different power. It has an x, but it has a different power, okay? The power here is 1, okay? Here is a like term, so I'm going to draw a box on that plus sign as well, okay? So the term and the operation in front of it is all included in the same box. And it doesn't look like anything else because x squared is not the same term as x, and 9 is not the same term as 5x. Okay, so I have two different terms. Now I'm going to change my color. I'm going to look at my constant next. I'm going to draw a circle this time. Circle around my 20. Okay, obviously anything with an x is not going to be similar terms. So again, I'm going from left to right when I'm looking at my terms, okay? It's organizing and eliminating it down to one number. So these x's aren't it, and the only thing that's left over is a -9, and that is a constant. So there's two constants in this equation, and now I'm going to look for a number, x squared. Change my number again, my color again. Now I'm going to draw a triangle around like terms. So if I find something that is alike to this 3x squared, I'm going to draw a triangle around it. Okay, even though there's no number in the front of this x, there's always a 1. So that means that this term and this term are both similar to each other. Okay, they are like terms. So let's do some like terms here. Okay, so my first one, again, I have 1, 2, 3, 4 y's and 1 x. So I'm going to combine my like terms. So I have my y, x, y, and then I also have an x. So I'm going to combine my like terms now. Look at all my red squares. I have 1, 2, 3, 4, so that gives me 4y. And then I also have plus x. So it's a way for us to condense really big equations and make them smaller so that we can solve. Let's take a look at the next term, 3x plus 2y minus x plus 7y. So let's combine like terms. I have 3x. Okay, 2y is not the same term as 3x because there's a y here. That's a different variable. But minus x is a similar term because there's a coefficient, 1, and we always assume that there's a 1 in front of an x with no number next to it. So that's a similar term, and then we know that y is not a similar term. So let's look at our next terms that we can combine. We can do plus 2y, and we can do plus 7y. Okay, so I'm going to look for all my squares and combine them together. 3x minus x, that means I'm going to have 3 x's, and then I'm going to take one away. So that gives me 2 x's, and then I have 2y plus 7y. So if I wrote that out, so I have 2y, 1, 2, and then I have 7 y's, 1, 2, 3, 4, 5, 6, and I'll add another 7 there. So I'm going to count my y's. 1, 2, 3, 4, 5, 6, 7, 8, 9 y's all together. Okay, so that is my equation. Okay, so notice how it's a lot easier to just simplify it than to just leave it out like this. Okay, it's a lot less work to solve and combine like terms. We organize everything, it'll be easier for us to solve later on. Okay, let's take a look at our next problem. Ooh, we got a couple ones there. So we have 5, and it doesn't look like any other constants are there. So I look for my next terms that are alike. I have an 8x squared. I also have a 2x squared. No, whoops. Change that to a different shape so it's easier for me to look for it later on. And I have a lonely 3x. So now I'm going to combine like terms, look for my circles, and all I have is my y. Then I have 8x squared plus 2x squared. So that means that I'm going to add those two numbers together, which gives me 10x squared. Then I have only 3 minus x, or sorry, minus 3x. And that is my term that I combine. Okay, and then let's look at my last one. Here I have 2 different coefficients and two different variables. I have a z and I have an x. So let's look at my z's first. I have 2z and I have plus z. And then I also have 4x, no other x's. So I change my shape, my 9. So now I'm going to combine my like terms. Look for my circles. I know that there's a 1 in front of that z, so 2z plus 1z gives me 3z, and then I subtract 4x. There's no other terms like 4x, and then add 9 at the end. Next, we're going to practice a little more.